Hello, and welcome to Buffalo National River. My name is Casey, and I'm one of the park rangers here.
And I'm Lindsay, the community volunteer ambassador here at the park. Today we're at Lost Valley, one of the most popular trails in the park.
This is an excellent location to see how the rock and water come together. The special relationship between rock and water at Buffalo National River provides us with places to learn and to play. We have a special guest today, Dave Jackson. He is a professional caver and an educator. He'll be walking us through a yummy experiment to teach us where the rock comes from at Buffalo National River. Take it away, Dave.
This is Dave Jackson with CaveSim, and my son and I love cake. And did you know that it does not have to be somebody's birthday for you to make a cake? We are going to make a very special kind of cake today called a karst cake. And this is an idea that we have invented completely from scratch, and it's going to be really fun and tasty. So in order to be ready, why don't you get a piece of paper and a pen or a pencil? Ready? Got your paper? Okay, great. Go ahead and write down how you think the word karst is spelled. Take a guess about how the word karst is spelled. Karst means cave landscape. So if you're in an area that has sinkholes on the surface and caves under the ground, when you are up on top, standing on the surface, the land that you see is karst. Here's how karst is actually spelled. K-A-R-S-T. Were you close with your guess? Go ahead and write down the correct spelling. K-A-R-S-T. This interesting sounding word comes from a very ancient word kara, which meant stony in a language that was used in Europe between 4,500 and 6,500 years ago. So now back to our cake. We're going to bake a layer cake, and the different layers are going to represent different kinds of rock, including limestone, sandstone, flint, and shale. Once our cake is finished, we're going to pour liquid on it to see how water would flow through karst and out into rivers and lakes. And then we're going to eat our cake. To make our cake realistic, we're going to model it after the Buffalo National River in Arkansas. The Buffalo National River is an area of the United States that has a lot of karst, and it's also a very, very beautiful place with very important resources for people. If we could slice the Buffalo National River in half, which we would never actually want to do, it would look like this. On top, we have grass and other plants, and we're going to use this fondant frosting to represent that layer. Under the plants we have soil, and we'll grind up these Oreo cookies to make the soil. Under the soil we have limestone, and we'll bake a cake using this yellow cake mix to represent the limestone layer. Do you know what kind of rock limestone is? We are going to bring in our resident geologist to tell us more, but if you have a guess about what type of rock limestone is, write your guess down on your paper now.
Hi, my name is Tracy Jackson. I'm CaveSim's resident geologist, and today I'm out here in the CaveSim trailer. Most large caves are made of limestone. Do you know what type of rock limestone is? Write your guess on your paper. There are 3 rock types. Any rock you find anywhere is going to be one of these 3 types. Sedimentary rocks form when little tiny pieces of stuff like sand or mud pile up over long periods of time. When the sediments dry out, like dry glue, they become stuck together, becoming sedimentary rock. Sedimentary rock often feels grainy or sandy in flat horizontal layers of sediment. Imagine if you never drained your bathtub water. You would get a lot of gunky sediment piled up on the bottom of your tub. Go ahead and write sediment on your paper. We also have metamorphic rock. Metamorphic rock is just rock that's been squished enough that it got warm enough that it changed shape. Write metamorphic down on your paper. Even though metamorphic rock is formed by heat and pressure, it's not melted. This often makes metamorphic rocks look folded, smeared, or even swirled. If we do melt the rock to make that red hot liquid that comes out of volcanoes, then we've made the 3rd rock type, igneous rock. Write igneous down on your paper. Igneous rocks often have crystals that grow and form as the liquid rock cools back into a solid. So the 3 major rock types are sedimentary, metamorphic, and igneous. So what type of rock do you think limestone caves are made out of? Write your guess down on your paper.
If you said that limestone is sedimentary, you are correct. Limestone is made from the shells of lots and lots of little tiny dead sea creatures that piled up under the ocean. These creatures had calcium shells, just like seashells at the beach, and when these creatures died and piled up on the sea floor, their shells stuck together to form limestone. We're going to add some sprinkles to our cake to represent some of the larger fossils found in the limestone around the Buffalo National River. Under the limestone is flint. Native Americans used flint to make arrowheads, and the American colonists used flint in their rifles during the Revolutionary War. Another name for flint is chert. Go ahead and write down chert, C-H-E-R-T, chert, on your paper. Take another look at this arrowhead. What kind of material does it look like? Does it kind of look like this glass? Why do you think that is? It's because the basic ingredients are the same. Do you want to tell us what is the chemical formula for glass?
SiO2. Another name for it is silicon dioxide.
Silicon dioxide, very good, or SiO2. Does glass do a good job of holding water?
Yes.
Yes, it does. So it's going to be very interesting to add a glassy layer to our cake because this layer is going to do interesting things to the water as it flows through our model. Of course, we want to be able to eat the cake, so we're not actually going to add real glass to our cake. Instead, we're going to use these chocolate chips to represent a glassy layer. We'll melt them together with a hairdryer, and when they cool, they'll form a hard layer. Just like the limestone, the chert formed when little tiny shelled sea creatures died and accumulated on the bottom of the sea floor. What does accumulated mean? Go ahead and write down your guess on your paper. The difference between the sea creatures that made the limestone and the ones that made the chert is that the chert-making creatures had glassy shells instead of calcium shells. Oh, and do you want to tell us what is accumulated?
It means built up.
Built up. Under the chert we have more limestone. Why? Because different kinds of creatures lived in the seas at different times. So during some times in the past we had more calcium-shelled creatures building up, and at other times we had more glassy-shelled creatures building up on the sea floor. Anyway, we'll use more of this yellow cake to represent this limestone layer. Below the limestone we have shale. Shale is another sedimentary rock, but it's made of mud and it's very dense. Because it's so dense, it doesn't like to let water through. Go ahead and write down the word dense on your paper and take a guess about what it means. If I have a pound of feathers and a pound of rock, which one is larger? The pound of feathers is larger because there's more space between the feathers, and there's less space between the molecules of rock, and so this is more dense. It is more pushed together. Anyway, shale is more dense, and it doesn't like to let water through. We're going to use this chocolate frosting to represent the shale layer. Under the shale we have even more limestone and some sandstone, and we'll use more yellow cake for that. Speaking of cake, it's time to start baking. The first step is going to be to make this yellow cake, and don't forget that you can follow along at home with either yellow cake or chocolate cake, any kind of layer cake that you have. Under our yellow cake, we're going to use parchment paper to make sure that it doesn't stick to the pan. If you don't have parchment paper, it's okay. Just coat the pan with butter or with cooking spray. If you do this, make sure that you don't use waxed paper. Instead, use parchment paper because waxed paper can catch fire in an oven. We also want our cake to have hills and valleys, just like real limestone. So we're going to put parchment paper on top and put beans in certain areas to make depressions. As you can guess, a depression is a low spot. If you want to impress your friends and sound like a mathematician, you can call these local minima. While our cake bakes, we're going to make some soil. We'll take these Oreos, open them up, and scrape out the filling. You can go ahead and eat the filling, but we'll grind up the cookie part to make soil crumbs. And if you haven't started following along yet, don't forget that there's still time to catch up. Go grab some Oreos. Now it's time to crush our Oreos. You could use a mortar and pestle, or I'm going to use this meat tenderizing hammer.
Is that because you are eating my frosting?
Hey, stop! Sharing means caring. One of the things that you'll notice about the Oreo crumble is that it's very porous. Porous means that there are a lot of little air spaces or pores in between the crumbs. Go ahead and write porous down on your paper. In addition to the cookie crumbs, I have some chocolate frosting here. Which one of these things do you think is going to be more porous? Which one is going to have more airspace inside of it? A science guess is called a hypothesis. Create a hypothesis about which one of these will let water through more easily, the cookie crumbs or the frosting, and write down your hypothesis on your paper. Our cake is done. Let's start building our karst model of the Buffalo National River. We're not going to make an exact replica, but the model will illustrate some interesting concepts. First, we'll put down some sandstone. Then we'll add shale. Now we're adding limestone. Notice the fossil sprinkles. The Buffalo National River is home to some very cool fossils, including crinoids, brachiopods, bryozoans, and some trilobites. These creatures lived 541 to 252 million years ago, but thankfully our sprinkles aren't nearly that old. Tasty. Now for a chert layer. Remember that chert is also called flint, and its basic ingredient is silicon dioxide, just like glass. Chert nodules, or lumps, can form in limestone, and if there's enough SiO2, silicon dioxide, the chert nodules merge together, making a hard layer. We're putting chertlet chips, chocolate chips, on the limestone, and we're using a hairdryer to mostly melt the chips. We did cheat with our chert, and we did have to pour some molten chocolate on top to bind some of the chips together. Now that the chocolate has cooled and hardened again, you can see that it's mostly a solid layer, but there are still some spots where there are holes in the chert. Now we're going to add more limestone, then dirt, and lastly, grass and other plants. Here we are building some houses. Notice that the ground has hills and valleys. If rain falls on this ground, where do you think the water will go? Write down on your sheet of paper what path you think the rain would take. Are there certain layers that the rain would go through? Are there some layers that would block the water? Where will the water go then? Instead of using water, we're going to use milk because then we can still eat our cake when we're done. We're also going to put blue food coloring in the milk just to make it easier to see. It's raining milk! We're going to end this video here to give you the chance to make your own cake. Make sure you look at the next video to see what happens with our amazing creation.
Whoa! I hope you saved some cake for me. Thank you so much, Dave, for teaching us about the karst landscape that is Buffalo National River. Now I know that I'm standing in front of a sedimentary limestone cave, and that the many layers of rock in the park hold and form the Buffalo River.
Next time you're at the park, investigate and identify the rocks that you see all around. I'll see you out there next time.
Hello, and welcome to Buffalo National River. Ranger Casey here.
And I'm Lindsay, the Community Volunteer Ambassador. Last week, our special guest, cave instructor Dave Jackson, showed us a yummy experiment that explained the karst systems here at Buffalo National River. If you haven't checked that one out, be sure to watch it.
Now that we've learned a little bit more about how water and rock interact to make the karst landscapes at Buffalo National River, let's talk with Dave about water conservation. He's going to tell us this story once more through his yummy cake experiment. Take it away, Dave.
In our last video, we made a layer cake to represent the karst of the Buffalo National River. We had just started to spray milk on the cake to see how water flows through karst. Let's pick up where we left off. It's raining milk! Notice that the milk is running downhill into these depressions. These are places where the limestone has collapsed because of underground erosion, and we call these sinkholes. The milk is flowing into these sinkholes and disappearing. If we look on this side, we can see the milk flowing down through the limestone, but it stops when it hits the chert. That is, except for right here where there's a hole in the chert. If we go back over to this side, the milk is flowing off the chert layer and into this valley. If we added a lot of milk, then what would we get in this valley? Write down your guess. If you said a river, you are correct. This is where the Buffalo National River has carved a channel over a very long time, and the river is fed by these springs on the steep riverbanks. As we saw, some of the milk goes down through the chert, so we can have springs at different levels. Of course, the Buffalo National River is also fed by surface runoff, which we can see here. But down here, notice that the frosting, which is shale, blocks the milk completely. By doing this experiment, we've learned that different types of rock have different permeability. More permeable rock lets water through, while less permeable rock forces water to flow on top instead of going through. Remember how you made a hypothesis about the Oreo cookie crumbs and the frosting? Was your hypothesis correct about which one would let fluid through easily? The Oreo crumbs are much more permeable to milk than the frosting. And that means that Oreos do a better job of allowing milk to flow through than frosting does. When rain falls on the ground, the permeable rock of the Buffalo National River allows the water to flow through it, and that water eventually ends up in the river itself. So now let's talk about the river. What do you think people use the river for? Write down some ideas. Next to each idea that you write, draw a check mark if people need clean water to do the activity that you wrote. Draw an X if polluted water would be just fine for the activity that you wrote. You can pause the video here if you need more time to write ideas. Okay, so let's compare our lists. Here's what I have on my list: swimming, kayaking, canoeing, a source of drinking water. Notice that I have check marks next to every single item, which means that in my opinion, clean water is needed for all of these activities. Oh, and don't forget fishing. After all, if you don't have clean water, there won't be any fish to catch. Let's go back to those houses up on top here, and let's go inside one of the houses. Where does everything go when you flush?
To the wastewater treatment plant.
But in other houses, it goes to a septic system. When septic systems are properly designed, installed, and maintained, they can be a safe way to dispose of human waste. But if they're not done properly, raw sewage can leak out of the septic system before it has the chance to fully break down. If it leaks, it might go to this house over here, and it might get into the well, which can make these people sick. In our model, you can actually see runoff from this house here, up on top of the hill, down to this house in the valley. It can also make its way into the river, as you see over here, and that causes a lot of problems. For instance, algae loves to eat sewage. Now, algae are not inherently bad organisms. In fact, algae is the reason that our atmosphere has enough oxygen for us to breathe. When the Earth first formed, there was very little atmospheric oxygen, and organisms like algae started to produce oxygen via photosynthesis about 3 billion years ago. These organisms changed our atmosphere, filling it with the oxygen that we need to survive. However, as with everything else in life, there is a balance. And if there's too much algae on the surface of the water, everything else that lives in the water will die. Why? Because the algae blocks the sunlight that other aquatic plants need to survive. It's also true that when algae absorbs sunlight, it heats up the water. Warmer water is bad for several reasons. The algae likes warm water, so even more of it will grow. And warm water holds less oxygen, so species like fish have a harder time breathing. Algae do produce oxygen via photosynthesis, but only during the day. At night, instead of turning CO2 into oxygen, algae turn oxygen back into CO2. The rise and fall in oxygen levels stresses aquatic organisms. Dense algal mats can also cover important habitat for aquatic organisms, causing creatures which are mobile to move to more crowded and less ideal places. Some benthic, or bottom-dwelling, organisms aren't able to move away, and these creatures are simply smothered. We shouldn't blame our problems on algae, because algae are actually the reason that we have enough oxygen here on Earth. Algae only become a problem when humans alter the environment by increasing the Earth's temperature and by adding too much nutrient, like sewage or other fertilizer, to the water. Not only can too much algae be bad for the amazing river and cave life in the area, but it will make the water polluted. Toxins from algal blooms can make people and pets extremely sick. How can we prevent this? We can make sure that the sewage and chemical waste that we produce doesn't get into the groundwater. Sometimes that means we need to make difficult decisions and not build certain things, like factories, homes, and farms, in places where leaks will be a problem if they do happen. Because, as we know, accidents happen. Back at our karst cake, there's another thing you should notice. Do you see this ridge here in the middle? Notice that we put all of the milk on this side of the ridge, away from the river. Did the ridge stop the flow of milk under the ground? No, it didn't. This means that surface features, like this ridge or valleys, do not necessarily prevent polluted water from getting to the river. If we're going to protect our water and the creatures that live in it, we need to understand what's happening underground. A scientist who studies how water interacts with and flows through rock is called a hydrogeologist. The word hydrogeologist has three parts: hydro, geo, logist. All three parts come from the Greek language. Hydro means water. We drink water to stay hydrated. Hydro, hydrated. Hydro, hydrated. Geo means earth, like the sport geocaching. Logist comes from the word to speak. It's also related to our word logic, which means careful thinking. So a hydrogeologist, hydrogeologist, is someone who thinks carefully about how water flows through the earth. Hydrogeologists sometimes use a safe chemical that is a very bright color to trace how the water flows underground. That's one of the things that we're doing with the blue food coloring in the milk. A hydrogeologist could put this brightly colored dye on the ground up here, and they could see where it comes out again. Sometimes they discover that the water appears and disappears multiple times on the surface before ending up in the river. One of the neat things about a dry riverbed, like the one in this picture, is that this might actually be a losing stream, where the water that's flowing on the surface goes back under the ground into the limestone, and maybe even into a cave, like we see over here on the back of our model. Speaking of which, caves are another important reason to protect our water. Because I'm Dave Jackson and not Elon Musk, I can't go into outer space, but I can explore under the ground, which is a lot like exploring other worlds. Like other caves around the world, the caves of the Buffalo National River are amazing, beautiful places. So I really hope that if you haven't made your own cake yet, you'll go back through the video and give it a try. We'd love to see what you come up with, so be sure to post your photos or video of your karst cake online. And remember that there really are things you can do to help protect your water. Try using less water on your lawn and in your house, and be careful about how much fertilizer you put on your plants, because algae loves fertilizer. And no matter how young or old you are, you can help by teaching other people about the importance of protecting our water. A great way to teach other people is to start by asking them a question.
Thank you, Dave. Buffalo National River has the word river in it, so we know that water is super important to everyone's experience here. And now we also know how that water runs through our karst landscape to get to the river, and how we can help to keep that water clean.
Thanks so much for learning with us today. Hope to see you playing out on the river soon.